Sorry girls, like I was saying, that our discussion was hampered by the connectivity, I think, from the service providers themselves of Zoom. But I was still explaining something about the quadrants. We had ended on the second quadrant where you had also verified that sign is positive in the second quadrant. So in the third quadrant, we have tan as being positive if you verify by checking on any angle between 180 degrees and 270 degrees. Just check through using any of the angles you want, as long as it is within this range here. The other thing is avoid boundary angles of 180 degrees and 270 degrees, such that you do not have things like infinity where you get math error. Then for the fourth quadrant, you will also verify that cosine is positive while the rest are negative there. So in general, we move through an anti-clockwise direction or movement such that we get these positive angles, but when we are starting from 0 degrees, which is at the positive x-axis. Whenever you deal with these x and y axes, and you are talking about the point of intersection of the two axes, you have 90 degrees there. So here we have 90 degrees. Then we have the positive x, and on the other side of the y-axis we have the negative axis, the negative x. This one here is like a mirror of x, just like the x-axis is a mirror of y. What is here is what is here, but this time around when it is negative. When you look in a mirror, for you are facing the other side. However, the mirror shows you that you are facing the opposite direction. So the x-axis is a mirror of the y-axis, while the y-axis is a mirror of the x-axis. Whenever we are dealing with trigonometry in the unit circle, we are going to draw a diagonal line from the center to the circumference. That is the first thing when you have finished now drawing these axes there. You have perfect axes? Yes. We have a vertical line, a horizontal line. Now you draw a diagonal line from the center of that circle to the circumference. And then after it has reached there, close this angle here, this angle theta, this angle, and call it any angle. For us, we are calling it here theta because it is what we are used to. However, if you find the angle A, do not run away. So we have theta, and then for anything to be called a triangle, it must be closed. So you can't talk of trigonometry when you are not talking about a triangle. We must close this angle here such that we have a triangle. However, we do not just close it. We close it at an angle of 90 degrees. So we must form a right angle at this point here. So what do? From where you have touched the circumference, you just drop a perpendicular line, a vertical line towards the horizontal line. And where it touches, it is automatically going to form 90 degrees. Looking at this, here we have x, and then here we have y. But since this one is a unit circle, we always say that the unit circle is a circle with a radius of 1 unit. So there is 1 unit here which we must respect. Now, when you look at the rest of the circles, supposing you have to form an angle, let's call that angle alpha. You will form the angle between a diagonal line and a horizontal line. All angles in trigonometry are formed between a diagonal and a horizontal, especially when you are talking about the unit circle, or you are talking about angle of elevation, or you are talking about angle of depression. So we have this angle here, but for us we have said that you must drop a vertical line to touch the circumference where you have seen here. So where this line meets the horizontal becomes your 90 degrees. At this point we are saying you are not going to just leave it like this. This one is going to be y because it is vertical. This one is going to be x because it is horizontal. However, you don't just put it as x. Any vertical line that drops below the x-axis, that one qualifies to be a negative y. That is why below the x-axis we have the y values as being negative. And now when you talk about from the y-axis going towards the other side of x, you will always have negative xc. It is the reason why you will find that some of these ratios are negative in these quadrants here. Why? Because there is a possibility of having a dimension, either the opposite or the adjacent, as being negative. So if one of them is negative and you are talking about SOHCAHTOA, you realize that you are having a negative ratio somewhere. The hypotenuse, which is that radius, is always neutral, or it is positive. We shall call it positive. It does not change to a negative. So for it, it remains 1, or it remains the dimension you have called it. It does not change its sign. That's why we say it is neutral there. If you have, let's say, here tan is positive. Why is it positive? When you look at tan alpha is going to be opposite, which is negative y, out of the adjacent, which is negative x. And whenever you divide a negative by a negative, you must automatically obtain a positive. So that is why in this quadrant you will find that tan is positive and the rest are going to be negative. We can verify with the sign. Sin alpha, we are looking at the third quadrant here. Sin alpha is going to be opposite, which is negative y out of the hypotenuse, which is always a positive, and this one is right now talked about as 1. So sin alpha is going to be a negative divided by a positive, you get a negative. That is why we shall maintain that sin alpha is negative. So here sine and cosine are negative. Why? Because when you look at the divisions here, x is negative, y is negative. However, the hypotenuse is neutral. So we are going to keep on having such a kind of arrangement. So this is the brief explanation of what was remaining, such that we can always have these questions answered. One thing we need to remember is that whenever we are dealing with the unit circle, we have to talk about the angle, then we need to talk about the quadrant in which that angle is. So you talk about that angle and the quadrant. Here we have acute angles, here we have obtuse angles, and then here and in the third and fourth quadrant we have reflex angles. So I want to thank you so much for being patient, and please watch this video and then you can always refer to it as a completion of the lesson we've just had. Thank you so much for attending.